Hello, everyone. My name is Aliona. I'm a team member of DLT Hub. DLT Hub is a company behind DLT, data load tool. It's an open source Python library for data loading, for data ingestion. And today, Alessio will present you a workshop about designing and scaling a data operating model. So, Alessio, can you introduce yourself?
Yes, thank you. How do I present? I will just start presenting then. 1 second. Are you able to see my slides? Okay.
So, guys, can you hear Alessio?
Can you hear me?
I can't hear you for some reason, but probably it's a problem with my...
Yes.
No, everything should be fine. Okay.
So you can hear me?
So yeah, they can hear you. It's just my problem from my side. So Alessio.
Okay, but they cannot see the slides.
I can bring your presentation on stage and you can start it.
Okay, good. All right, so I hope you still hear me because now I don't hear Elena anymore. Sorry for this. Are we still good? Okay. All right, thank you. So I will just quickly go into the topic. So first of all, thanks for joining. And we're going to be talking about scaling analytics delivery. And that's going to be a topic which is going to be not only about technology, but also about basically operating models and processes and different things that we normally see. Just before we get started, I just want to set basically the expectations. Basically, this would be a good webinar for you, or you would be in the right place. If you are either already leading a team of analysts, or you're planning to lead one, or you basically are working in analytics as of now, but you have more demand that you can handle. This is quite an important topic because we are not going to be touching on anything connected with how do you prove the value of analytics in this webinar. So we are assuming that, okay, there is already quite a lot of business demand or quite a lot of interest in what you are doing, or you are planning to have a lot of demand in the future. And the problem is mostly about how do I scale analytics and insights with my team and in my company. And then the other thing is you are in the right place is also if you already have something in production or you are soon going to have something in production. This is because we're going to be talking a lot about best practices for basically scaling analytics. And in order for you to scale something, you first should have something in production already that is proven and it's working. Okay? And of course, if you are not in these three areas, but you are interested in how analytics would look like, in terms of as you grow in your career path or as you continue to do analytics in the future, this is also a good webinar to start. Just a little bit about me. I actually started my career in corporate finance. I was working on different areas of the P&L and the balance sheet. I did also some months of work in internal audit. And then I transitioned basically to analytics a little bit over 8 years ago. Just to give you some context in numbers, since we are all data people, I have been as a lead or as a developer in more than 60 analytics projects over the last 8 or so years. I built 3 data analytics departments, usually on average having 30 plus data professionals. And I co-developed 4 data platforms, and then I also was overseeing the development of different other data platforms. So my goal here with this webinar is basically to help you understand how to scale analytics, and basically without making the same mistakes that I've made, okay? So in these 8 years and during all of these projects, there are quite a few lessons learned that I have accumulated, and I would like to share them with you. Okay, so before we go into solution mode, let's talk about why analytics delivery breaks down, and also what is analytics delivery. So, as analytics professionals, we want a lot of things. We want to influence business outcomes. We want to generate insights and data that is trusted. We want to be seen as reliable and trustworthy partners, and we also want to collaborate with other analysts in the company. On top of that, these are expectations that usually as data professionals, we have about ourselves. But on top of that, we also have expectations from the business. And what I have seen over the years is that the expectations from business to what analytics should deliver have been going higher and higher. So now the expectation, let's say that you have one data analytics department in your company. The expectation is that for that analytics department to be able to support different departments, so from finance to supply to marketing, operations, supply chain. And that means that you need to be able to be quite good in understanding and defining different metrics. So you can go from a very financial metric like accounts receivable, bad debt, or cash flow, all the way to very marketing or very sales metrics like price erosion. And those are very different metrics in very different departments. And the expectation is that data analysts would do not only all of the technical work that they are usually doing, but they actually would also understand these metrics and the business domains that they are working with. So we have all of these dreams, okay, and all of these expectations. And I would see that in many cases, these things are basically not happening, right? We are getting stuck, or we have basically a lot of blockers that are blocking us from reaching these outcomes. And if I can summarize why, what is really blocking a lot of analytics teams and a lot of analytics professionals, I will say that there are quite a few failure points, okay? The first one, which is, I would say, quite an interesting one because we are data analysts, but actually one of the major reasons why a lot of analytics outcomes are not delivered is basically lack of data. And that's not just lack of ingestions per se, but it's also not understanding how the data actually is defined in the source applications. So I have seen companies that have piled up a lot of basically custom code in their ERPs. We're talking like 20 years of, for instance, ABAP code in SAP. And so even understanding the definitions of what happens in the source application is a problem. And so that's one of the main reasons why, one of the key reasons why a lot of analytics projects fail, or analytics delivery fails. There is also the classic lack of standard and documented processes, teams working in isolation, and there is quite a bit of over-engineering going on right now. So these are, let's say, some of the top reasons that I see. So as I said, we want to achieve all of these things. Let's say, if we can summarize this slide, is we want to be influential, we want to have business outcomes, we want to prove that analytics is providing value, and we want to be really good at that. But then we are getting basically all of these blockers or all of these failure points. And then when we think about it, or at least what I see a lot happening, is that these failure points are quite clear, everybody understands them, but then the solution mode is, let's go and buy more technology because that's going to solve basically what we see. And in some cases, that's true. Okay, there are some technology choices that will definitely help you. But in other cases, you end up in a lot of over-engineering because in reality, you're not really having a technology problem, you're having other types of problems. And if we can summarize really the root cause behind all of these issues, for me, in most cases, what I would say is the lack of an operating model. And by lack of an operating model, first of all, what is an operating model? An operating model is a system of people, processes, technology, and mindset to deliver solutions. And in this case, is to deliver analytics. So when I say a lack of operating model, what I mean is, okay, we have a technology in place, we have some ideas in place, we have even some things in place, some products, some analytics products in place, but we don't have an operating model. An operating model, it's a bit like an operating system on which you basically build and run your analytics solutions. And I believe that one of the misunderstandings that we have in data is that an operating model is not 100% made out of technology. So there is a technology component, but you also need to consider at least two other components. One is the people component, the other one is the process component. If you break it down into people, process, and technology, then on the people side, you really need to understand what are the roles and the responsibilities that I need in my analytics organization in order to deliver solutions. On the process side, you want to talk about workflows, or basically what are the processes that we need to deliver solutions. And on the technology side, you want to think about how do we support delivery, how do we support enablement and technology, but without doing a lot of over-engineering. So these are basically three key elements, and this is also what it means to have a good operating model. It can get a bit theoretical, so what I will do is I will give you some hints of how this looks like, and it really depends also on your maturity. So if you're starting out, you definitely should not look into every single detail of roles and responsibilities or every single aspect of your process. There will always be some percentage of your processes that will be hidden and undocumented, no matter what your maturity is, okay? But my goal here is to give you a tool, which is basically this understanding of the operating model, to give you a tool to understand how to look at analytics delivery problems from another point of view, let's say a less technology-based point of view, a more like service or business-based or process-based point of view. Cool. So let's go. Okay. So to make things more understandable or to make things easier to teach, what I have done in this webinar, I have basically looked at the operating model and took some elements of it. And one thing that I think is very close to what analytics professionals are doing, we can define it as workflows. There is even some material, even from DBT, defining what workflows should be and what workflows are. So it's a terminology that already is in the industry. And in the context of this webinar, a workflow, you can see it as a series of steps that a certain persona has to do in order to deliver an analytics solution. Okay? So if we look at some of the examples, let's say that you are a data analyst and you want to deliver a Power BI dashboard. There are some steps that you need to do in order to do that. And here we have put an example. So, first step is exploration, another step is transformation, then you need to do some visualization, and then you need to do some sharing or publication of your insights. So when you look at the steps, you can then define what are the tools for each step, and also how do you integrate all of these tools. So for instance, when do I use Python and when do I use SQL? When do I commit my code to GitHub? When do I build a CI/CD pipeline that connects my GitHub with my data catalog? So these are all questions that you can answer once you have a very well-defined workflow. And on top of that, you can also use the workflow as a guidance for documentation, because once you have a very well-defined workflow, you can basically document, okay, this is how a data analyst is doing their work. And these are the steps, these are the tools, this is how you get access, right? And this brings you closer and closer to having an operating model, right? Because it provides you processes, capabilities that will help other people to get onboarded and to get their job done. One thing that I want you to notice is if you look at the data, let's look at the platform engineer persona in this slide. The platform engineer persona has very different steps, right? So they are providing infrastructure, they are doing CI/CD, and they're doing deployment pipelines. So they have very different tooling than the data analyst persona, right? So they have Terraform, Kubernetes, GitHub, many other tools, but they're very different. So this gives us also a bit of a hint of how you can then take these workflows and also use them to figure out the roles and responsibilities. And especially if your team is not very big, and this I've seen in many cases when I had smaller teams, or when I was starting out with projects, usually you would have a team of 2, 3 people, 4 people. It will happen that the same person is doing multiple workflows, right? They have to be able to do data analyst job, but also the data engineer job at the same time. And that's totally okay. Because what is okay, it is okay to have people that are wearing multiple hats, as long as you know what those hats are. What is not okay is when you have a lot of hidden processes and workflows and you don't really know exactly what people are doing or how they are accomplishing their job. Because then it becomes a problem in terms of, okay, how do I hire new people, or how do I build a backup for these people, and so on and so forth. So what we will do then in this webinar is we will break things down into these 4 elements. And for each element, I will come back to the workflow topic, right? So let's look at the workflow as the major component of an operating model. And the 4 elements that I have here are mapping, roles and responsibilities, data platform, and data governance. And then for each element, I will give you some idea or some examples of some tools that you can use in order to fulfill this workflow element, okay? And these are not complex tools. The majority of them are either Excel templates or diagrams that you can use directly from the slides, or some materials will also be shared after the webinar. Cool. So we can go to the first one, which is workflow mapping. Bring hidden processes to light. So I was getting philosophical here. So let's look at an example. Okay, so this is a workflow diagram of an existing process in a company doing. This is a company that is working in healthcare, and they have a huge, very big R&D department. In this case, R&D is also doing a lot of quality work. So they are mixing R&D and quality tasks. And you are gonna probably wonder, why is he talking about R&D? It's because in this particular situation, a lot of R&D engineers are doing actually a lot of analytics work. And what I have done with them is I mapped out what happens when they receive a customer complaint. Now, this company receives quite a bit customer complaints because of the nature of their product. And every time they receive a customer complaint, they have to do a root cause analysis. A root cause analysis means they need to understand what was the reason of the product defect. And there are two reasons why that's important. The first one is because if it's responsibility of the provider, the supplier of the product, they have to issue a credit note, so it's a cost, okay? The second reason is basically they want to increase the quality of their products. So they want to continue to improve the quality, and they want to make sure that they find the issues as soon as possible, so that they stop shipping products with defects. Because when it comes to quality, you want to catch the product defect as early as possible, because it would be cheaper to fix it, okay? It's much cheaper to stop a car that is not working on the production line than to have to do a callback from the customer, okay? So that's the concept. So in this context, root cause analysis is very important, and especially the speed of root cause analysis is very important. So, and what you see here is, okay, we realize we have a problem, okay? So we have a problem, and then the first thing is, do we have the data to analyze this problem? And I don't even have the yes, because in this case, usually the answer is no, we don't have the data to fix this problem. Then what happens? They go, we're talking about R&D engineers, okay? So people with engineering degrees, they are now spending their time downloading data from ERP systems, SharePoint, and other IT systems. They do everything in Excel. They then manually consolidate this data in Excel. And when they have to do actual statistical analysis, and I'm still trying to figure out the Minitab, but I think what Minitab is doing here, because you can do some statistical like correlations, you can do them in Excel, but there are some specific statistical things like process capability and curve fitting, other type of analysis that Minitab for some reason makes easier. And so what they do is then they upload from Excel to Minitab, which by the way, Minitab is also a desktop tool, which means a lot of problems when data size is too big, because everything runs on their laptop. And then once they have done the statistical analysis, they put it in a PowerPoint, and they send it over to different internal stakeholders via Excel. So I think it's very obvious that there are a lot of problems here, a lot of hidden processes. It's not a great workflow. And what happens here is, when it comes to root cause analysis, because of this very inefficient workflow, you can see a root cause analysis lasting anything between a couple of days to a couple of months. So, you have a product defect, you want to go as fast as possible, and it takes 2 months to figure out what happened. It's not great, okay? So when it comes to this type of work, what is very interesting is when you do this kind of current state workflow analysis, it doesn't take much time. This kind of work, if you sit down with the right people, you get it done in like 1 hour, 2 hours tops. And it's also a good exercise to make sure that everybody understands the problem and what is your starting point with the issue. Then you could also wonder, one last thing on this topic, because I think it's quite important. You would also wonder, okay, but why should I care? They are actually solving their problems. The company is still making money, so why should we care? And I give you one reason why we should optimize a workflow like that, which basically means we should automate as many steps as possible. When the steps are manual, the steps are not replicable. So when you automate, everything is very auditable, because everything is automated via code. So you know exactly what are the steps that are taken to do a certain analysis. So there is also a pretty strong auditability problem here. Like, okay, we do an analysis, but how do we know for sure how this analysis was done? How can we review the steps? So anyway, this workflow is pretty bad. So I think everybody understands it. Let's look at what we do when it comes to, okay, let's look at the future state, right? So this is now a workflow. Hopefully you can see it properly. This is now a workflow that has been optimized, right? So we looked into the basically standard best practices, and we said, okay, how can we design a better workflow? This workflow, by the way, for time reason, is not exactly the answer to the previous one, but I put here some boxes to show you how we can improve it so that we can fulfill the previous workflow with this one. But here you see already some differences because first of all, there is a review process, right? So top right, you see that there is a review process. So at least there is some auditability or some review of the modeling that is being done. And then you see a bunch of tools and a bunch of automations in this workflow, right? So starting from the left, the analyst persona would develop their models. We are talking here a persona that is developing only in SQL. So they develop code in SQL, in this case DBT, SQL with DBT. They would push code to Git. There is a review process, okay? And then when the pull request is approved, there is a CI/CD pipeline, and that is pushing code, not pushing code, that is pushing metadata to the data catalog, and basically making the scheduler aware that, hey, there is a new pipeline. In the case, not in the case of DBT, but in the case of basically when they are pushing an Airflow or a Prefect or a Dagster, then the scheduler also would be involved. And then what I have done, I have added some basically idea of how we could replace Minitab. So of course there are different statistical tools in Python. You have Pandas, Polars, Modin, Spark, and so on and so forth. But what I want you to take from this workflow is that even if we added, let's say, a statistical tool, what we would do is, okay, how can we do that as code? How can we involve, how can we have that step also part of our code-based workflow? Yes, so I think this is good. This is another workflow. I cannot give you a lot of details about this one because I'm not super strong when it comes to Terraform, but I wanted to show you this one because it's an example of a non-data analytics workflow. Again, code-based workflow. I shall say that we are very opinionated when it comes to this. Like when we can, we always try to have a code-first approach to everything that we do. And that is why these two workflows are very basically code-based. One thing also you can see in this workflow that at least I'm able to explain is that you have two reviewers, because in this case there is the DevOps team and the IT team doing a review. So my point here is you will have to design your workflow based on the particular situation that you have in your company, following some principles, right? Like for instance, for us, code first is a principle that is worth following. So whenever we design a workflow, we have that in mind. Okay, and now you can put workflows also in the context of observability. And again, depending on your level of maturity, but I wanted to touch on two topics. One is basically the data pipelines, and obviously probably many of you already are using Airflow or Prefect or Dagster, but if you do everything as code and you're pushing everything and you have CI/CD pipelines, that means that you can also monitor production. This is a screenshot of a Prefect Cloud dashboard, but it's basically monitoring all of the pipeline runs. But another thing that I see less, even in more technical teams, is you can also get more into the data catalog topic, but unless you're using dbt Cloud, you can also integrate data catalog with your CI/CD pipeline, because basically what you can do is when the code is pushed to production, you can get the JSON files out of dbt, right, based on your code, and you can send them over an API endpoint. So if your catalog has an API endpoint, you can also do that integration. So my point is, if you design workflows in the right way, you can also use that to facilitate what it's going to be your operations when things are in production. That was the point of this. Okay, so this is about mapping. So as you can see, coming back, one tool that I find very useful, very simple, is basically what you see here. This is called a swim lane diagram. And you can just copy this from the slide, or there are also Excel templates. And it's very useful to start really with the mapping of the current state. And I cannot stress this enough, because every single time I meet a new team, they will tell me that the current state is obvious and we should focus on the future state. So I will instead push to map out the current state. It's 1 hour of work, but it gives you a lot of pointers to understand what exactly is broken in the analytics workflow and what needs to be improved and why. Cool. So that was about mapping. Then we can also look at roles and responsibilities in the context of workflows. This is the fun part. I think all of us know that there are a lot of roles in data today. So we usually call it data analysts, but you also have data scientists, you have data engineers, you have ML engineers, AI engineers these days also are becoming popular. You have data platform engineers, you have DevOps, cloud, data. There is quite a lot of roles, okay? And my point is that one, with a lot of roles, you really need to figure out how you're going to collaborate. So, and some roles might not be in your team, right? For instance, right now, I'm dealing with a customer where they have their own cloud architect in IT. So that means I need to figure out how is going to a collaboration between us and them going to look like, right? And it sounds obvious, but if you don't get this sorted at the right level of detail from the very beginning, it's going to be very painful, usually sometimes for years, depending on what kind of companies you're working in. So the first reason you want to get your roles right is to understand who is doing what. And then you have a second reason, which is that you want to understand how many hats are people wearing. So you might have a data analyst who is acting also as a data scientist, as a data engineer, and as an ML engineer, and that's totally fine. But it's important to understand that, because otherwise you would have a lot of hidden processes and a lot of hidden responsibilities, and whenever the person moves on or things change, it will become very difficult to make sure that your production systems are maintained. So when it comes to roles, to give you a quick overview, the most useful tool that we use is called the RASI. So what you do is you look at who is responsible, who is accountable, who is consulted, and who is informed. I think many of you probably know this tool already. It looks like this. What I can add in terms of experience or what I've seen in the past to this tool is you can try to map basically the tasks by workflow. So if you have figured out, okay, I have this many workflows, then you can say how many tasks I have for each workflow. And then for each task, you can ask yourself which role is fulfilling this task. So in this case, for instance, develop SQL queries and transformation. We have a data analyst, obviously, who is accountable, who is responsible, but we also put the business who has to be consulted and informed. So this is a little matrix, but it really helps. You don't have to go into every single task that everybody is doing, but what is important is to figure out what are the key tasks that have to be discussed and have to be agreed. Because especially when it comes to production, I'll give you an example. I have had a situation in the past and this is a fun topic, where at some point I was running an integration pipeline. So I was actually managing data in real time with Redis pipelines, Redis queues. And at some point we stopped getting data from France. Or actually not that we stopped, we were not getting it at all because we went live, we had a bunch of countries and France was not coming in. And it took us like a good part of a week. And basically what happened is the firewall of this customer was rejecting characters in the French language. And it was really difficult to solve it because it was not clear who was responsible for the firewall. And this is the level of detail, or these are the kind of things that happen and that have to be discussed, because especially when there are tasks that are not falling in your team and there is another team in charge of it, it's really important to understand who is doing what. Because in this case, we had a production incident for multiple days. First, because it was really difficult to understand the root cause, and then to even figure out how do we get it fixed, because who is responsible. Okay, so as a bonus point, I just want to touch slightly on this, since we are talking about roles and responsibilities, and there are some organizational elements of basically roles and responsibilities that you can take into account. I think everybody here knows what the data mesh is. And the idea of data mesh being that you have all of these domain teams working on different business domains, and they have data contracts, and there are producers and consumers, and there is a shared data platform. Here, what I can tell you is I tried to implement data mesh once, and it's a very hard concept to explain to management. And also when it comes to roles and responsibilities, it's a bit of a mess because, okay, we are gonna have this very decentralized solution, but who is responsible for the common good? The common good being, the common stuff. Basic question, like who is responsible for data privacy policies, or who is responsible for auditing data accesses, or who is responsible for standard data sets that everybody is using, like master data. So what I prefer to usually use is a model which, in my opinion, is actually quite similar to data mesh, but it's just easier to explain, where you have a hub and spoke, right? So you have a hub, which is usually a centralized data analytics team. So that could be actually your team, or usually a team that reports either into IT or into a decision maker or a C executive. And then that team becoming the hub, what they can do is they can collaborate with other teams in the businesses. And these are called the spokes. I think it's a very simple model to understand. And what is also really interesting, similar to RASI, in a hub and spoke model, what you can do is you can figure out, at the task level, what can be done in the hub and what can be done in the spoke. So it answers a lot of questions. For instance, should the spoke be able to do data ingestions? It's a yes or no question, right? And it's going to depend on your situation. Usually, the tendency is whatever is close to business, so the higher is the business proximity, so the higher is the level of understanding of the business that you need to have to perform a certain task, the more likely is that this task will be in the spoke. And the other way around, the more general knowledge, or the more technical knowledge you have, the more likely is that this could in theory be centralized. When you centralize, you can be more efficient. When you decentralize, you are less efficient, right? But what you can definitely not do is having a central team doing Power BI and analytics for everybody, depending on how big your company is, right? But if you're dealing with a company, I don't know, of 1,000, 2,000, 3,000 employees, and you are expecting one team to do analytics for everyone, it's just not doable, because you are not going to have enough domain understanding, business understanding, to be able to be providing useful insights for anything from finance to marketing to supply chain operations, inventory management, and so on. So that was my little, let's say, lesson, or at least what I learned from my experience. It's probably a good idea to try to do data mesh, but to maybe talk more about hub and spoke, because it's definitely a lot easier to explain. We'll see maybe in the future data mesh becomes more clear to everyone. Right now, it's not. Okay, so now workflows and data platform. So in the context of workflows, a data platform is basically a platform that enables personas to run workflows, okay? But I wanted to be very clear on one thing. From my very opinionated point of view, a data platform is a service. And the goal of the service of a data platform is to support workflows. What I mean by that is that the data platform team is a service provider. And I don't want to get lost with definitions here, but I think it's very important to understand the difference between a service provider and a technology team. Okay, a technology team, they are focused on technology, they are focused on architecture, design, getting the right tools, making sure that the tools that we are onboarding are the right ones and they have the right life cycle on that's their job. Okay, a service provider is a team that could be doing also some architecture work and some technology work. Usually that's how I like it, that the team is doing also that part of the job. But they also have another part of the job, which is they need to support all of the people using the data platform. And that means, not only being able to respond to tickets, but also being proactive in fixing pipeline problems, being proactive in training other users, being proactive in documenting things, being proactive in basically doing what we are doing here, defining workflows. So it's a much bigger job than only doing the technology aspect of the platform. And I'm saying this because this is one of the biggest mistakes I see when I usually look into what data platform teams or cloud teams do, because they focus primarily on technology, and they basically lose everybody else in the organization. And then what happens is you have this amazing shiny data platform which nobody is using because everybody is building their own little side IT project, and it's called also shadow IT. So what you want to do on the data platform is to really look at it as a service and not just as a technology exercise. And when you look at from this point of view, so you want to have a data platform which provides a great customer experience. You want to keep an eye on cost. Unfortunately, I have yet to see a company that is very interested in paying a lot of money for services. Usually, if you end up in the capability service space of your company, you're going to have some level of cost efficiencies. And that's really important, and it's very tricky because you might have a couple of years where nobody cares about your rising costs, but eventually somebody's going to ask, why are we paying so much for this? So it's very important from the very beginning to keep an eye on cost and to actually be cost effective when it comes to providing services. You want to manage the full life cycle, so everything that enters the data platform and should enable a workflow, first of all. So you should not insert things in the platform that don't have a workflow, but also you should already keep in mind that whatever technology you buy today, you might have to decommission tomorrow. And then I usually highly suggest for every data platform to have proper SLAs and metrics around reliability, responsiveness, so to measure the quality of their service. But said all of that, on the technology side, this is typically what we go with. And again, because of the very componentized nature of workflows, like you can design them and you can have different steps for each workflow, we usually prefer a more modular architecture. So here you would probably not see tools like Databricks because we would rather focus on modules. Of course, you can also go for bigger tools and figure out how they fit in this architecture, right? So I believe this is quite clear. When it comes to ingestion, I put Python DLT, Airbyte and Fivetran, but because I told you that we are very opinionated, we are very code-based, we in fact usually would either go to Python or DLT. I have tried to use UI-based ingestion tools, not Airbyte or Fivetran. I used Azure Data Factory, and many years ago Alteryx. I always ended up regretting it. So on the ingestion, then you have on the landing, you have the typical S3. On the preparation, you have the typical basically SQL and the modeling DBT and different other tools. What you should take from this slide is that the architecture is something that you build based on what you need to deliver, right? And I think if you start from the workflows, first you figure this one out, and then you can say, okay, what tools do I need to enable these workflows? And I believe this one is actually a more important slide, which is the component life cycle. I think everybody can understand what a life cycle is. So a life cycle is how do you go from beginning to the end, right? And in this particular context, is like, okay, how do I go about adding a new tool, a new component to my data platform? So first I do an assessment, then I do an implementation, then an integration, operation, support, and disposal. And you want to include disposal, which means you want to include already, hey, I buy a tool, I should already know how to decommission if I need to decommission. But one thing that is important, connected to what I said before, is you see these two red blocks here. One is integration and the other one is support. I put them in red because these are the ones that sometimes data platform team forget, or they think they are not in the scope of what they are doing. Integration is really making sure that whatever tool that we are inserting in our data platform is actually supporting or enabling a workflow, and it integrates well with all of the existing stack. Okay, this is also, if you are working with the code-based workflows, it's a lot easier to do because you can inject in your platform much smaller components and make sure that each one of them fits really well. For instance, if you're already using Airflow or Prefect, it's very easy to introduce DLT into that workflow, right? On the support side, it's making sure that whatever new component you add to your data platform, you should have already support plan in mind, right? And by support, I mean documentation, training, tickets, and so on and so forth. Okay, so I have one last topic, which is usually the fun topic everybody likes, which is data governance. And on data governance, I was not sure if I should add this or not, but then I did, because we are talking about scalability, we are talking about scaling analytics delivery, and one of the major pain points as an analytics lead when I'm trying to scale analytics, when scaling in this context is also getting more users, right? It's not just about having more analysts, it's also about having more users, more people looking into my recommendations, my reports, my dashboards. One of the major pain points is actually access management, because depending on how your company operates, companies can get very confused about access management. And when you start going into the discussion, who should have access to what data, it can become really complicated. And it can take sometimes a lot of time to come to decisions. So what I did here is I wanted to add data governance, but only in the context of access management, because data governance is a huge topic. But in this particular webinar, I wanted to give you some hints of what to do when it comes to access management, for this to not become a blocker, because there is a big risk here that access management becomes a blocker if data management or data access is a topic in your company. If management in your company cares about who can see what data, then it's a good idea to have some thought about how do we have a simple approach to access management and how do we avoid the complicated stuff. Because if you get into the complicated stuff, it's a never-ending story. Okay, before we go into the specifics of access management, I just wanted to simplify the topic for everyone, because everybody talking about access management, usually it gets very confusing in terms of exactly what are we talking about. And there are two concepts really that we need to consider. One is assets and the other one is resources. Assets are basically the artifacts, the things that you are producing as an analyst. So that can be dashboards, Excel reports, applications in some cases. Basically, these are the things that you produce, the outcome of the analytics job. Resources are basically the resources that you need in order to produce those things, okay? So while assets could be things like tables, Excel files, dashboards, resources are things like Kubernetes clusters or S3 buckets or ADLS or even databases. So a database is a resource, but a table is an asset in this definition, okay? We don't need to get philosophical. It's just a way to understand as an analytics organization what are we giving access to, because sometimes we forget that we are also giving access to resources. We are not only giving access to assets. But in general, no matter if it's an asset or a resource, what you want is to have one access policy, which, the standard one is the role-based access control policy, and to keep it as simple as possible. And I will give you some examples of what that means in the next slides. You also see some examples here, but I don't think it's very, very visible. So we can steal one concept from data mesh, which is data domains. And if you have good defined domains, and I mean, by well-defined, I don't mean that they have to be perfect, but you have some idea of what your data domains are. An example of a domain could be sales, finance, or supply chain, but you could also be much lower level than that. You could be like sales North America, sales Europe, right? So those are all domains. And usually a domain is something that is built around a department that is usually managed by a decision maker, right? So you can also look at your organization, how your company is organized, look who are the decision makers and see how you can basically organize domains around these roles. And the reason why I'm saying that is because the decision maker is also the one that will, in theory, help you manage the policy, the access policies for the domain. But once you define the domain, you define basically the personas, so this is connected with the workflows. You create groups, you map the users to the groups, and then you do some technical work, access configuration, to basically coordinate, synchronize the groups, and then you have audits. I'm just gonna take a step back from this and explain what all of this means. Is very simply, a domain becomes an Active Directory group if your company is using Microsoft, and your Active Directory group is what you're going to use to manage accesses to resources and assets. It's very simple, yet somehow people always find way to complicate this. If you keep it simple, let's say that you have let's look at an example later, because now I'm going into the specifics. Let's look at the example here. I wanted to put two examples that are exactly the same, but one is the total finance domain and the other one is finance commercial, to just explain that you can define domain however you want. And again, base it around your organization or what is the decision maker that you're working with. As you can see, second step is actually assign the domain owner, which should be in the business. And then what you do is you create an Active Directory group. So you have a data_finance, data_finance commercial in the second example. You assign users to the groups, and then you assign assets and resources to the groups also. And that's it. right? And you keep it simple. What that means is, if once you have defined a domain, you have defined an Active Directory group, and you also have defined a list of people that can have access to these domains and can have access to these assets. It's very simple. I think everybody can understand that. You will be sometimes challenged on this being too simple, and the main thing I can think of is if you're building report for a sales organization, that's my experience at least, usually you end up having conversation about row level security, because there are even some laws, like in Germany, I remember there were some laws about sales peers in the same level where should not be able to see each other's data. There was something about that was very complicated. But in general, when it comes to a sales organization, you don't want a salesperson from Germany to have access to the entire world data or even to the entire Europe data. So that's where you end up talking about row level security. And now, if you have good master data, so you know exactly this salesperson from Germany, what are the customers, right? So there is a mapping between the Germany sales territory and the customer IDs. Then you can build row level security, usually in the dashboarding tool. In Power BI or Tableau, it's very easy to do. So in that case, you do have to get a bit more complicated than the example that I have given here. The challenge you're gonna get if you do row level security inside a dashboard is that's in the consumption layer. Why don't you do it in the database layer? And we can go really deep into this topic. You can ask if you want, but my advice is, if you can, keep it simple, because this can get really complicated. Especially the row level security can become really complicated, and also it can slow down your reports. So that would be my advice and my takeaway and this is my take basically on data access management. Okay, so next steps. I was able to finish under 1 hour, so that's good. This is my last slide. So if you want to do if I advise you to try to take some action after this call if you can. The easiest thing you can do is you can map your current state. So you go in the slide of, the mapping slide, and you take the swim lane diagram and you try to map out one of your workflows, and you see, how it is. Maybe it's really good, maybe it's really bad. You just map it out. Then what you do is if you want to get deeper and deeper into it, so step 1 is enough. It's already enough of a good action, in my opinion. Sometimes understanding your current state is 80% of the picture. But then you can go into, okay, let's now look into the future state. So you can map out how you would like things to look like. So you copy paste your swim lane diagram, and then you ask yourself, how can I improve this, right? And you create a new workflow. And then you basically ask yourself, how can I bridge the gap? So step number 3 is like, okay, this is my current state, this is my future state. Why am I not in future? What do I need to do to get there? What are my gaps? And then there's a 4th step, but that we have here is we do have a survey or an assessment that you can take. The link is there, and this is a self-assessment. So it has a few questions. It's an alpha version of an assessment that we haven't finalized this yet, but this would give you also a score of your current state. This is mostly focused around data platform, so it depends on what is your issue, but if you want to basically assess your data platform, you can also take this assessment. So this is basically what I have. Thank you for listening. Are there any questions?
It looks like no questions.
Okay.
Thank you, Alessio, for the amazing talk. It was really interesting to listen. So I think that's it. Thank you everyone for watching it, for joining us. We will send a link to recordings and all the follow-up material